All right, so what you guys already know about Pythagorean theorem, let's go over that. You guys obviously know a squared plus b squared equals c squared. All right, we know that. I'm hoping we know that. What's the segment called that I plug in for c? Hypotenuse. And the two segments I plug in for a and b are referred to as my legs here. Good. Those are my legs. And also, maybe you don't know, but this can only, Pythag can only be used in a certain circumstance.
It has to be a right triangle.
It's got to be a right triangle. Can't just be any old triangle. It's got to be a right. So only used in a right triangle. So let's apply it to some geometry that we've already seen this year. So you see my parallelogram up there. Yeah, parallelogram. So let's go back to properties of the parallelogram. I'm asking you guys, hey, how about the perimeter of that parallelogram? All sides added up on that parallelogram will equal to what? And then leave your answer in simplest radical form. Well, we know one side's 11, right? Bottom side's 11. If we know our parallelogram properties, what's another side? 11. Also 11, because what property are you using there, Audrey?
In a parallelogram, opposite sides are congruent.
Boom, opposite sides congruent. So I know this side up here has got to be 11 feet. The only two sides I don't know are the other two opposite sides. But does everyone see how I'm going to apply Pythagorean theorem to find one of the sides? All right, I'm going to use this right triangle where I already know two sides, and I'm going to find the side of the parallelogram. And that is where you guys are going to take over for me.
I thought the 9 feet was referring to the whole thing.
Nope, 9 feet. Here you go. That's why this bar is here to here. All right, 9 feet. The rest 2 feet. So a squared plus b squared equals c squared. Turn it over to you guys. Plug in for a, b, and c for me right now. Here we go. Let's start it off right. 14. Ellie's not here. How about 2 instead? Quincy, what am I going to plug in for a and b here?
6 and 2.
6 squared plus 2 squared. I am looking for the hypotenuse in this problem. Go ahead, guys. Keep going. You guys see simplest radical form. Let's break that sucker down. Let's break it down. I got 36 and 4. Gives me 40. So it looks like you guys are breaking down the square root of 40 for me. And I'll give you guys a second to do that. And let me know what you end up with. Square root of 40. And if we haven't, let me know. But I think we've had a lot of practice breaking down radicals. And 40 is not a large number. Five. Let's roll, Hayden. What do you got for me there?
2 radical 10.
Good. Perfect. Radical 40 breaks down into 2 radical 10. Any issues? All right. Perimeter time. Perimeter time. I knew at the beginning of this problem 2 sides were 11. And we just did Pythagorean theorem to figure out the other 2 sides were 2 radical 10 and 2 radical 10. Now the question is, what the heck can I combine? What can I not combine? Because you cannot combine all 4. Right? You cannot combine all 4 because these 11s do not have a radical 10 with them. So you cannot combine all 4. You can combine the 11s. We can all add 11 and 11, right? And you can add the 2 radical 10s because radical 10 is underneath both of them. Now, how do I add them? This is what I get a little nervous with in this unit because I don't know how much time you spent on radicals last year with going home in March. Anybody know what I get with 2 radical 10, 2 radical 10? Sophia?
You have 4 radical 10?
Yeah, you don't add the number underneath the radical. You add the numbers outside. Good. So 4 radical 10. And hey, that's it. That's as far as we go here. I cannot combine 22 and 4 radical 10. And the only thing I would probably ask in an honors class, if the problem has units, so does your final answer.
And you can't simplify the 4 down again.
No, the 4 is not underneath the radical. So I don't even talk about simplifying it, right? Only if it's underneath the radical. Any other questions there? How we got to 22 plus 4 radical 10? Only can combine numbers with the same radical. All right, let's go to 2 then. Another geometry type problem using Pythagorean theorem. I first, before we even talk about the problem, I want to first introduce you to the most famous character in a honors geometry word problem. Your first meeting of Big Al. All right, he is going to be a legend in these parts from now on in this course. If anybody knows anybody who has taken honors geometry, you got brothers, sisters, or friends. Well, let's face it, friends really for some of you, but ask him about Big Al. All right, ask him about Big Al. He will be a common occurrence on problems, homework, tests, and quizzes. We're going to get to know Big Al quite a bit and what he does with his life.
He must have a lot of problems that require geometry skills.
Darn right he does. All right, legend, Big Al. All right. So he's got to avoid walking through a pond. Even though he is that legendary, he can't walk on water. So to avoid going through the pond, he walked, oh boy, south and east. Oh boy. Do we need to get out the old compass here and remember what is what here? Do they still teach never eat soggy wheat or no?
Never
Never
eat
soggy
soggy waffles.
waffles.
Oh, geez, they changed it.
I feel like south and north are really easy, but then like east and west.
Yes. So there you go. If anybody needed help with the old south and east. How many meters would he have saved if Big Al was if he could possibly walk through the pond? All right, well, 34 meters south, we go down, right? So here's 34. East, we can see by my little directional arrow there, we're going to the right. So 41 meters to the right. So that's where he walked. He walked 34. So how many total meters did he walk right now? 75, right? So keep that in mind. He just walked 75. Instead of going through the pond, how can I find how long the pond is? There you go, Pythagorean theorem. That's where this comes into play now, the using of Pythagorean theorem. A squared plus B squared equals C squared. Turn it back to you guys. What are my numbers going in for the Pythagorean theorem? Twos. Hannah, what numbers do you want me to plug in for Pythag, Hannah?
34 squared plus
Yep.
41 squared equals C squared.
Good job. 34 squared plus 41 squared equals C squared. All right, you guys have your calculators. You're going. I want to make a huge point coming up right now. You guys are getting 2,837. You take the square root, right? Now, this is the first time I've talked about this year. Maybe teachers in the past have, but first time I'm going to bring it up this year. The problem says to the nearest tenth of a meter, but that direction right here, to the nearest tenth of a meter, that's for your final answer, not in the middle of the problem. All right? Nearest tenth of a meter is when we're officially done with the problem, we'll round to the nearest tenth of a meter, not in the middle. So what am I trying to tell you guys? That number you're staring on the calculator at, we don't round it. We don't round it because it could throw off your final answer. So we are, yes, 53.26349,594. The rounding directions are for the end of the problem when you're ready to box it in and circle it. All right, so that's how long it is across the pond. I didn't ask you how long it was across the pond, though. I'm trying to figure out how many meters. Yeah, meters he's going to save. So if he could walk across the pond, how many meters would he save? How are you going to get to that calculation? 7. Let's go, St. John. How are we getting there?
Can you repeat the question?
Okay. How do I know if he could walk through the pond, he'd go 53 and change. If he went south and east, he'd go 75. If he walked through the water, how much would he save? How do I figure that out?
75 minus the x, which is like the hypotenuse.
There we go. So I'm going to take 75, which is Big Al went around, minus the length of the pond. Now here's where we round. Here's where we round to the nearest tenth of a meter because this is our final answer. Everyone getting 21.7 meters. Remember, tenth is one number after the decimal. Any issues there? Using Pythag to figure out how many miles he would have saved. Good old Big Al.
Wait, wasn't Big Al in the same house?
Was what?
I was thinking, when I heard Big Al, I thought of Al Capone.
Maybe that was one of his nicknames. I'm not too sure. It easily could have been. All right, next.
Because of the different feeling.
He's not a mob boss. I will reveal his identity at the end of the year. All right, a little bit different now. How's those algebra skills? Let's find out. Pythagorean theorem, because I see a right triangle and 3 sides. All right, plug it in for me now. What sides go where? 2, 4. Emily, what sides go where here, Emily?
4x minus 4 squared plus 8 squared equals x squared.
Good job. X minus 4 squared plus 8 squared, or you could have them switched, equals x squared, hypotenuse. All right. Whew, here's the part I'm going to get nervous about is what the heck are you guys going to do about that? X minus 4 all squared. What are you going to do about that? That's what I worry about. When you square something, that means you're multiplying it by itself. So this right here, x minus 4 squared, is x minus 4 times itself. It is not, hey, I'll take that 2 and just kind of distribute. It's not, no, it's not distribution. It's an exponent. I can't distribute it. It's x minus 4 times itself. So I will give you guys a minute here to go ahead, double distribute, and FOIL. X minus 4 squared is x minus 4 times itself. All right, what do you end up getting when you do x minus 4 all squared? What's that come out to be? Let's roll. Emily, again, this is your problem. What do you have, Em?
X squared minus 16.
Oh, I think you forgot some middle terms there. I got the x squared, right? And then you do x times negative 4, which is negative 4x. And then you do the negative 4 and you get another negative 4x. Those don't cancel out. What do you get with those, Emily? Negative 4x minus 4x turns into what? Negative 4 minus 4. Negative, go ahead.
8x.
Negative 8x. And then your last thing that you said, what's negative 4 times the negative 4?
16.
Positive 16, all right? Everyone are okay here? Double distributing? Where that came from. All right, I still got plus 64 equals x squared. I think I can clean up the left side a little bit because I got 16 and 64, so let's clean that up before we do anything. And you guys can see, I got the old x squared working. Usually this is when you have a little throw up in your mouth because you know it's going to be factoring. Right? Stomach starts getting queasy. All right, so let's get one side equal to 0. But wait. When I get one side equal to 0, what's going to happen to those x squareds? See ya! They're gone, right? If I move this x squared over, move it over, they're going to cancel each other out. Oh, boy. Gone. So I have negative 8x plus 80 equal to 0. All right, there you go. Don't have to worry about factoring now. Just solve for x. Don't make it complicated for yourself. Just get x by itself. No need to factor now. Whew. Wipe the sweat off. Thought you were going to have to factor there. I hate factoring. I don't care. Value of x here. Let's roll 18. Let's go. Owen, what'd you get? Value of x.
X equals 10.
Darn right. Move the 80 over, divide by -8. Good job. 10, guys, ladies, 10. All right, all good on different ways we're going to use Pythag. All good, because now something you don't know about Pythagorean theorem. Believe it or not, you can use Pythagorean theorem to figure out if a triangle is a right triangle, an acute, which we talked about, all angles less than 90, or obtuse, one angle bigger than 90. Pythagorean theorem can be used to tell what type of triangle it is. Believe that, huh? How about that Pythag? Here's the deal. If I do a squared and b squared, then I do c squared, and they both come out to be equal. It's a right triangle. Shocker, I know. We've been doing that all year, right? If you use a squared plus b squared equals c squared, what do we say? What type of triangle must it be? Right triangle. Makes sense. All right, well, what if they're not equal? What if the a squared plus b squared side is actually bigger than the c squared side? So a squared b squared, I get a number. C squared, I get a number. What if the a squared b squared side was bigger? That triangle's acute. That's going to be an acute triangle. And then the opposite, if I do a squared plus b squared and it comes out to be less than the c squared value, we say it's obtuse. That's how I figure out what type of triangle I'm working with. Yes?
How would you know looking at an acute or an obtuse angle, which one, or triangle, how would you know which one to label as A and B and which one to C?
You tell me. What's always going to be C out of the three numbers?
I would say the longest.
You got it. Yep. Okay? Because if that's truly the remember, Sophia, if that's truly going to be the hypotenuse, it's going to be the longest side, right? So that's how we're going to figure it out. Yep. All right, here we go. I got two quick examples for you before we go on to the graphing one. 9, 12, 15. What type of triangle do I have? 9, 12, 15. All right, well, what I'm going to take is the two smallest sides for A and B. So I'm going to say 9 squared plus 12 squared. I'm plugging it right into Pythagorean theorem. Now I'm not going to put an equal sign there because I don't know anything. How does that compare to 15 squared? All right, so I got my A and B, which is 9 and 12, and my C, 15. How does 9 squared plus 12 squared compare to 15 squared? Let's figure it out. Let me know what you got for the values here. Holy jeez. Zach, let's roll. 9 squared plus 12 squared, Zach. What'd you get?
225.
Good, and then how about 15 squared?
225.
All right, so they came out to be equal to each other. Those are three sides of a right triangle. If they come out to be equal to each other, it is a right triangle. So 9 and 12 are the legs, 15 would have been the hypotenuse. All right, 10, 11, 13. What type of triangle am I working with now? 10, 11, 13.
It said to justify your answer. How would you frame it?
You're doing the Pythag and showing me they're equal. I don't need to see a statement or anything. All right, so for this one, 10 squared. Remember, you take the two smaller sides. 10 squared plus 11 squared. How does that compare to 13 squared? Crunch your numbers. Emily, going back to you. You got this. Redemption time. 10 squared plus 11 squared. Emily, what do you got?
221.
Good work. And how about 13 squared?
169.
All right. Thank you. All right. So what did we just find out by Emily's numbers? The a squared plus b squared came out to be bigger than c squared. So if you look up above, what type of triangle do I have if a squared plus b squared was bigger than the c squared? It is an acute triangle. If I could spell it. All good? Any questions? Because now here's where the complaining comes in. Any issues yet? All right, I'll give you a second. Go ahead and graph this triangle. How do I figure out if this is an acute, obtuse, or right? Okay, so here we go. How am I going to figure out if this is acute, right, or obtuse? Well, I got to know the side lengths. How am I going to figure out the side lengths? Distance formula or Pythag, right? All right, so let's make this easy so we don't have to take the rest of the class to do all this, all right? You guys in class, you have side XY, go. You guys at home, last names A through K at home. You guys have YZ, go. And then last names L through Z at home. You guys have XZ. You guys have XZ, go. Do I need, I guess I should, huh? Even though we're in January. Distance formula. The problem doesn't say anything about simplest radical form, so don't feel the need to. If you want to, fine, but don't feel the need to. Only simplest radical form when the problem states it directly. All right, here we go. You guys in class, make sure we jot them down, please. Jot it down. You guys in class, what do you got for me? XY. When you get there? Square root of 29. Make sure we jot it down. Square root of 29 was the distance of XY. You guys at home, last names A through K. What do you got YZ for me? There's a few of you there.
Radical 20.
There you go. Square root of 20. Good work. You could break that down if you want. There's no need to here. And then L through Z, majority, almost all of you at home. What do you got for XZ?
13.
Square root of 13. Square root of 13. All right, here we go. What are the two smallest sides here? Square root of 13, all squared. A squared plus the next smallest side, square root of 20, all squared. How does that compare to the longest side, square root of 29, all squared? What are you guys noticing when you square a radical? As you guys use your calculators now, what are you noticing? It's just the radical disappears, right? So you get 13 plus 20 and 29. So 33 bigger than 29. So the a squared plus b squared side came out to be bigger. So according to our facts, what type of triangle was this that we just graphed? I can't. Don't even go ahead. Don't even say a word.
It's acute.
There you go. The a squared plus b squared side is bigger. We say it's an acute triangle. All right, good work, guys. Good work. Questions on that one? All right, last one and we're done. Don't have to worry about starting the assignment because you're going to do it tomorrow again. All right, Big Al, once again. He's got two triangles. I got to draw them. He's got one that says 5 centimeters and 12 centimeters on the legs. And then he's got another triangle here where he's got 13 centimeters on the hypotenuse, 5 centimeters on the leg. Big Al says they're congruent. Little Mike says they're similar. Hey, are they both correct? So I can see most of you working right now to find the missing sides, so go ahead. So as you guys do Pythag, in the first triangle, you're seeing the hypotenuse is 13 centimeters. In the second triangle, you're seeing the missing leg is 12 centimeters. So first one, let's talk about Big Al. He says they're congruent. Are they? Are these two triangles congruent to each other? Ooh, 12. Here we go. Lucas, are they congruent?
Yeah.
Yes, they are. So first is yes, they are congruent. Because, why? So we had a method called side, right? What else? What other method could he have used other than side, being congruent? You could have used side, angle, side. Either one would have been fine. Or if you want to go really big time on me, HL. Yep, HL. All right, so they're definitely congruent. Now here comes the controversy. Little Mike, are they similar? Remember what it means to be similar. We had 3 ways to prove them similar. Are these two triangles similar to each other as well?
Something proportional to itself.
What do you mean?
Like,
What's the 5 match up with?
oh wait, never mind. Oh yeah.
5. What's the 12 match up with? 12. 13 matches up with? Are all the sides in the same ratio? 1 to 1, right? Yeah. So these are similar. So yes, they are similar because of, give me a method we talked about. I gave you guys 3 methods last unit. 3 methods. Anybody at home? 3 methods. One of the methods I could use here.
Side.
Yep, I could do side similarity. Or I could do side angle side similarity because you got that right angle there. So either one would have worked. All right, questions, comments? Again, don't do the assignment today. That's what you're going to have all class to do tomorrow. All right, is to do the assignment. So if you're coming into school tomorrow, make sure you have your Chromebook so you can access your laptop. All right? You guys at home, make sure you got your laptops with you so you can access the textbook if you don't have an actual one. All right, I'm not keeping anybody. You guys, I'll see you tomorrow. You guys at home, some of you coming in. You guys here can just relax. Nice little week here we got going.